We're going to continue chapter 1, right? And I have to say tomorrow. So we're going to focus on, right? We talked about the different types of data, right? Remember, we talked about the different types of levels, right? Nominal, ordinal, uh, ratio, interval, categorical data, all that stuff we talked about yesterday. Now we're going to talk about what are the different ways to collect sample data and how the collection of data can introduce bias. And then we'll do a tiny little bit of using Excel. We'll use Excel at least a little bit in this class. There are you can do a lot of stuff on Excel. I won't teach you everything that the book does because we'll teach you also how to use your graphing calculators, but we will do at least one project on Microsoft Excel. So hopefully you were able to get that. So section 1.3 is on collecting sample data, right? So we're going to distinguish between different types of sampling, right? We're going to talk about what's random and non-random samples, right? And we will talk about the difference between simple random. There's something that's random but not simple random. That one's one of the things that's can confuse a lot of students. We'll analyze different types of sampling methods and we'll classify different types of study, right? So let's get into that. Key concept. The method used to collect, right? So ideally, in a world that we didn't really need statistics, would be a world where you could just get information from an entire population, right? So, right, we can't do that, right? So if you want to know something about what all Americans feel about an issue, you ask some Americans. That some is the sample, right? And typically, it's a very small part of the whole group, right? So right? So one thing that I want to mention right now that is something that students think a lot about that it's not a slide to talk about, but I'm just going to mention, right? Students think, or anybody intuitively thinks, right, that like if I'm sampling the whole country, right, if I only choose 10,000 people in the sample, that's not a very good sample because 10,000 is a very small fraction of 330 million. And that is not true. The size, right? If your sample is a very small part of your population, that doesn't really matter. Sure, the number of people in your sample matters, and we will look at that later when we get into calculations. But this is something really important, right? And students, I say this, some students will answer this on some of our celebration of knowledge questions. The fact that a sample size is a small part of the whole, a small part of the population, is not really important, right? A sample of a couple thousand, a couple hundred can be very good, right? And answering questions about the whole population, assuming the sample is collected correctly, right? So sample size is important, but we're not going to talk about it now. So you're answering a question and you're referring to the size of the sample in your answer. At this point, that's wrong. So sample size does matter. What does not usually matter is how big that sample is as a fraction of the whole, right? So a sample of 500 voters is just as good for Chicago as it might be for the whole United States, assuming that sample is collected correctly, right? So of particular importance is the simple random sample, right? The reason why certain samples might not be good, right, are because the samples might be biased, right? If I wanted to estimate the median income of an American worker, right? And I used this class as a sample, it wouldn't be representative, right? Because you guys are much younger, so you're probably just starting your earning career. Some of you might work, most of you who work probably work part-time. Some of you might not work at all. It's not representative, and that's probably because it's not random, right? If something is random, it's more likely to be representative, right? If I randomly select 100 people, they're more likely to have the same age profile as the whole country, right? Or the same income profile, whatever it is. So, and we'll get to what simple random means in a little bit, right? There are things that are random but are not simple random, and that is confusing. So it's kind of this, right? And simple random samples are very difficult to collect for one reason, right? Even if I could simply choose 1,000 random Americans, I can't make them participate in my survey because it's a free country, right? So voluntary response is something that's very difficult to get around. There are some complicated statistical methods that you can use, but if the data is not calculated in the appropriate way, right, it might not be useful at all, right? There are lots of complicated statistical analysis, some of which you'll learn, much of which you won't in this class, much of which I don't even know because, you know, my background is more in pure math, right? I know enough statistics to teach a beginning statistics class, but I'm definitely not a statistician. But it's easy to understand, right? If you collect data in a biased sample, right? If you are trying to poll to figure out whether Donald Trump or Joe Biden will be the president a year from now, right? Or a year and a couple of days from now. If you have a method that oversamples Republicans or oversamples Democrats, it doesn't really matter what you do with your sample. How you analyze it, you're probably going to get an answer that's not right. Garbage in, garbage out, right? That's a simple process of information. So let's talk about what the gold standard would be. What would be the best sample, right? If you can't access the population, what is the best sample, right? And then we will talk about things that aren't quite as good as that. So this is called the gold standard because it is the best. So if best is where you can actually control, right? So suppose I have some weight loss pill, right? And I want to know if it works, right? Best would be if I had two groups, one who takes the pill and one who doesn't, right? I would want one who is in which sample. I would want those individuals to be randomly selected, right? If, for example, people got to, if you were part of the study and you said you can choose to be in the placebo group or the non-placebo group, right? You might say, well, I want to lose some weight, so I want to be in the group that is getting the treatment. Well, the people who want to lose weight might be different in ways that are significant to how the pill works, and the people who are okay being in the group that doesn't get the pill, right? The other thing is the placebo effect, right? If I say this pill will give you more energy, right? But it doesn't really. It just makes you think that because I told you that. That's the placebo effect, right? So the best part is a group where both, right? People who get the treatment, people who don't know whether they're getting the true treatment or they're getting a sugar pill, a pill that does nothing. So two groups are randomly selected, one treats, the other not. Subjects do not know which group they are placed in. We'll mention this later. Sometimes it's even better for the people who are doing the studying to not know which group it is, right? They might be invested. They are, right? They're invested in the pill working. So when they interview people who, if they know whether they took the pill or they didn't, right? That might change the way that they write down their observations, right? So sometimes it's good to have just one individual know who's in each group. That's double blind, and we'll talk more about that. So this is the best, but it's often not possible or not ethical. Imagine, right? It can be often very not ethical. I believe that this pill, right, will reduce the effects of radiation sickness if you're exposed to radioactivity, right? You can't choose one group to expose to radioactivity and another group to not, right? That's not ethical. So no one would sign up to do that. So that kind of comes up into two different studies, right? So here's an experiment, right? Apply a treatment to some group and proceed to observe its effects on individuals, all right? So individuals in experiments are called experimental units, or you've probably more heard subjects. That's when they're people, right? But I could be doing an experiment on bicycles, for example. You wouldn't want to call the bicycles subjects, right? Let's see if I'm curious, right? Like, does using this type of lubricant make the bicycle last longer. So then you might call them experimental units. An observational study, right? So an experiment might be, let's get some people, let's get some bicycles, let's see how how long their lifetime is, when they're lubricated, let's have some that aren't, and then that's an experiment, right? An observational study is one where you observe and measure specific characteristics without attempting to modify the individual study, right? So let's think of the same example with the bicycles, right? In one, I am selecting which bicycles, right, are having the treatment and which aren't. An observational study might be the same thing, but instead I just find bikes out in the world, right? I ask the owner of the bike, did you use this lubricant on the bike, or did you not, right? And then I can compare the people who say, yes, I did use it, no, I did not. So my question is, for getting statistical results, okay, so discuss with the people around you whether you think some advantages are of an experiment and an observational study. Well, just kind of talk about the differences between them and try to figure that out. I've apparently lost some of my slides, so I'm going to figure out what happened there, right? So just give that a shot, and then we'll come back together, right? Okay, so let's come together, right? What do we think? Which one do you think is going to give us better results? An experiment or an observational study? Some thoughts. Experiment is correct, but who has some different reasons? So why would you say, what do you think some advantages of an experiment is? Right, okay, so it could take longer, yeah, Jamari. Yeah, right, right. So yeah, there's an idea that maybe observational studies take longer, and that can be the case, right? And I think there's some intuition about that the experiment is better, right? But some people have a hard time breaking down one of the main things, right? And it's actually kind of the sampling method, right? So there's the advantage, but there's and I guess it depends on the circumstance. But one reason that the experiment is better is that there is not usually something called, which we'll get to. I'm gonna give you an example and then define it. Like it's called confounding, right? And the idea is that with an experiment, right, since the experimenter is either randomly or choosing individuals to be put into the two different groups, the treatment and the non-treatment group, you can know that the groups are similar, right, in important characteristics. In an observational study, that's not the case, right? So let me give you I like now that PowerPoint is now pretty good at suggesting background graphics for my slides. I did not choose this picture myself. So this is called the deadly ice cream scenario, right? And we're going to introduce a character that it's pretty silly, but you're going to learn a lot of him, right? Anytime there's going to be a person in any of your celebration questions or assignments, you're going to be hearing a lot about your cousin Drippy. I don't know how I came up with that name, but I did, right? So your cousin Drippy is a weird guy, and he's really interested in what causes drownings for some reason. I don't know, right? So let's think about this, right? So he obtains, right, per capita drowning rates, right? So out of how many people live in the city, how many drowning incidents were there in a year or whatever, right? And he also looks at what per capita, like what's the average amount of ice cream that people consume in this city, right? And he does this for 200 cities in the USA. So that's a lot of cities, right? So my question for first, y'all, is this an example of an experiment or an observational study that Drippy is doing here? Right, because he's not applying any treatment, right? But he is looking at the effects, right? And you would think that these two things have nothing to do with each other, right? But you can find out and discover that drowning deaths and ice cream consumption, you look at it city by city, are actually fairly have a strong correlation between the two. The more ice cream that's consumed in a city, right, the more drowning deaths there are. So, right, clearly drowning can't cause ice cream consumption. That doesn't make sense. So he concludes that ice cream causes drowning. That seemed like a valid conclusion. No, but like, it's kind of, is anyone made uncomfortable that these two things are so closely correlated? Because they don't seem like they should be. Any thoughts on why? Does anyone have, this is hard to come with. Anyone have any idea why these two things are closely correlated? Is it pronounced Monks or Munse? What do you think? That's correct. And that's an example of what's going on here, right? But can anyone figure out why these are correlated, but there's no cause? I can't see your name tag.
Oh,
Myra, what are you thinking?
I think that related with.
Okay, you got the, I hadn't thought about the body water thing, so I'll have to think about something on that, but you really focused in on one of the things that I came up with, or at least with the experiment came up with when they came up with this example. So, well, we're near a large body of water, but not right now. So, is anybody planning to go swimming outside anytime soon in our area right now? No, it's going to be below 0 degrees Fahrenheit by the end of the week, right? So like no one's doing that. And also when it's cold, what also are you not really feeling like eating? Ice cream, right? So what is probably happening is that there is co-founded, right? There is something here, right? So B and C are correlated, but they're both being caused by something else. A, right? So this is exactly what Myra was saying, right? So cities, right, that are hotter, right? People are both more like, I think today is a great day for a swim. You also think today is a great day for ice cream, right? So just what you're saying, I'm assuming cities like, maybe not near water, that was part of it, because you can swim, in pools and stuff, which I assume is where most people swim, right? But like in San Antonio, right, higher average temperatures, they probably consume more ice cream than we do in Chicago, right? And they probably spend more time swimming. And if they're there could just be more drowning deaths, right? Just by how things work, right? No one's swimming in this classroom, so no one will be drowning, right? So this is an observational study, right? What this is missing, right, is the lurking variable of temperature, right? That causes, right, temperature sees that as the temperature increases, ice cream sales increase and drownings increase because that causes more people to swim, right? And this effect is coming from the fact that it's an observational study, right, as opposed to an experiment, right? So we're trying to look at the effect, right? How does increased ice cream consumption affect drowning, right? The problem is that cities that have an increased ice cream consumption that have high ice cream consumption are different than cities that have low ice cream consumption in ways other than just ice cream consumption, right? So you have this confounding, right? You are looking at two groups, right, and seeing which group, right, has more of something, right? But they're different in other ways. So let's see how an experiment would get this, right? Experiment's not always practical. But if you have some groups that have high ice cream consumption, some cities have low ice cream consumption. If you could conduct an experiment, right, where all of these 100 cities, you randomly somehow, I don't know, just imagine you're God for a second, you somehow assign, and the people listen, in 50 of those random cities, you tell them, right, consume a lot of ice cream, and the other 50 you say, consume little ice cream. And then you compare drowning deaths after a year, you would find no correlation, right? It is the effect that the heat is causing both of those. So the two groups that you're looking at, those who consume high ice cream are more likely to be in the water, right? So those two groups are different in ways that affect the study. This is basically the idea of confounding, right? So so this is the main reason, right? Some of you talked about this, that an experiment is better, right? Because the people are more likely to be similar, right? Let me just try to think of another example. Let's say, that you look at how effective is therapy on people's moods, right? and you find out, hey, we've done an observational study, right? People who go to therapy, right, they generally have better moods. Now, that could be that the therapy causes the better moods, or it could be something causes therapy, and that same thing causes better moods, right? And it looks like the two things are correlated. So for example, if I just did an observational study, ask people, do you go to therapy? How would you rate your mood on a scale of 1 to 10, right? Well, perhaps let me just come up with something, right? Therapy is expensive, right? And it's not covered under a lot of people's health coverage, right? People who go to therapy on average are wealthier than people who don't. So maybe the fact that they're wealthier is causing them less stress. They don't have to worry about, you know, paying their rent, paying their car payment. So they're in a better mood. It's not the therapy that's causing it. It's the money that's causing both of them. But, right, I can eliminate this if I randomly select 100 people to go to therapy, right, and I pay for it, and 100 people don't go to therapy, right? Now, Elise, these two, since the 100 people are randomly have similar income profile, right? Any differences I now see in, well, these two groups are on average similar in every way, except one group goes to therapy, the other group doesn't, right? Now, if the therapy group is on average happier than the other group, we can be much more, it's still not certain, but it looks like, in this case, right, the statistics would suggest that the therapy costs, because that's the only important way that it's different, yeah.
How would that be ice?
The ice cream, you'd have to randomly select it. This one's a little bit harder. The ice cream, you would have to randomly select some cold cities, some hot cities. Yeah, you would have to assign cities to eat certain amounts of ice cream, which isn't, it's not really something you can do, right? So that would be hard. Or you could choose, yeah, you could just choose people all over there, all over the country, right? And assign some of them to eat ice cream and some not to, and see if those who eat the ice cream drown, if those who don't, right? And then you would probably see it doesn't really, like on a personal level, it wouldn't matter because, you know, the people in, regardless of whether they're eating ice cream in a cold city and they don't really want to, they're not also going for a swim, right? So that you would see no effect, right, in that case. So the idea is when you are the experimenter, right, the two groups are different, right? If the groups are selected correctly, only in what you're changing. Out in observational studies, there could be, right, people self-select into doing particular behaviors, right? Eating ice cream, swimming, whatever. So those groups are likely to be different in other important ways. So it's very difficult with observational studies to do that. All right, now as observational studies go, right, they're not the best, but there are different ways to work on them to make them better. Sometimes that's the best you can get, right? Like a lot of people want to know, what are the effects of lead, childhood lead, on criminality as an adult, right? Like, no one wants to, yeah, like that'd be unethical to randomly get 100 children, in fact, you know, put lead into 50 of their diets, right? That's nuts. So there are ways to do this, right? So when you look at an observational study, right, and you choose people for your observational study, you can try to work that out in some ways, right? Like if you're observing 50 people who had childhood exposure to lead, 50 that don't, you might have to intentionally choose people who are similar in other ways, similar in diet, right? They have the same average diet, there's the same number of poor folk and rich folk in each group, right? That would not happen by chance, right? So with observational studies, there are some ways to try to correct it. And we're not going to get a ton into exactly how to do that in the class. The important part to understand is why they're inferior to experiments, right? And it's this idea that they're different, that the two groups might be different in ways that you wouldn't have under an experiment. So let's talk about some of the different types of cross-sectional studies, right? So data are observed, measured, and collected at one period, right? And not over a point in time. So I could do an observational study, right? Where I give surveys to everybody in a particular community about how often they use their cell phone and maybe some other things. I could try to find some correlations, right? And that would be a cross-sectional study. So you're studying a lot of people all at once. So you kind of get a cross-section. A retrospective study would be when data are collected from a past time, going back in time through records, right, or interviews or so on. These also have that, data has gone bad since then, but they can be more interesting. Sometimes you can know more about them, right? For example, right? I mean, last year last semester when I first taught this, Oppenheimer movie came out, right? There was a Trinity test in New Mexico, right? There are now studies on like how did that affect those communities in the long term, right? So they've gone back, looked at death records, people die younger that were near where the first atomic test occurred. What are some other effects? You can also see more long-term effects, right? Certain things that may have been caused by that nuclear explosion, right? May have taken years to manifest. So that's that. And of course, anytime I'm looking at records, right? If, I don't know, I want to look at the city of New Mexico and they say, all right, here are some of the records, but the records from 1955, there was a fire that year and we hadn't digitized it. You cannot recover those records. So obviously, retrospective studies, right, are limited. You can't choose what to measure. You have to see what they happen to have records and you can measure what's in those records, right? If you're curious on what sort of television shows the people like to watch, that data is probably just not available, right? Prospective studies are ones that might be collected from now and into the future, right? So these can take a long time, right? And take a lot of funding, right? So you might, right? They do these, right? One of them, there's a book that's fairly famous of, I think it was some women, it was like maybe, 8 white women from one high school in Iowa. They experimenters, I don't remember exactly what they were studying. I didn't read the book, but they met with them and they interviewed them every year for like 30 years to see like how their lives would turn out. And then they wrote a book about it and on some of their findings and stuff, right? Now that's more qualitative than the stuff we'll talk about here, but that's an idea, right? And these things take a long time, right? I've seen these studies now where they try to find, kids, right, in different schools, see how their lives come out. That could be an observational study. A lot of people want to know what the effects of childhood lead exposure, right? So I'll get to you in just a sec, right? You might find children who have different amounts of lead exposure, right? Interview them for the next 30 years, see which of them end up graduating from college, see who end up being, parts of social problems, right? Going to prison, having depression, drug abuse, right? And the studies have shown this, that, childhood lead exposure, right? Even adjusting for income disparities that might cause those, can cause higher criminality and lower achievement, lower salaries 30, 40, 50 years later. So it's one reason why it's very important to get lead out of the water. Yeah, you had a question or a comment? Yeah. Yeah. And if you really want it, and right, some of these take a lot of funding, right? You tell someone, and my wife is a researcher in business. Actually, I might talk a little bit more about this. It's business statistics, right? There's a big her field. There's a big push to publish. So not a lot of people would sign up to start doing a study that you can't publish your results for 30 years. But some might be even more interesting, like, let's collect this whole group, right? Have studiers check in with us the whole rest of our life. Which of us will develop cancer in our late 50s or early 60s? How are they similar, right? So you can follow a group for many years, right? And then see which one of them develop cancer. That could be a very interesting study, but it could take a very long time to get the results. That answer your question?
I was talking about people who have eating like.
Oh, yeah. Yeah, that could work too, right? And then it depends on what you want to collect, but yeah, that could definitely be an observational study, right? So, and definitely could be a perspective one. Sorry, I didn't quite understand what you're getting at, but yeah, absolutely. Another thing that is good about experiments that not is great about observational studies is replication. If I do an experiment, right, and I tell you how I did it, right? Why you want are things to be simply random, right? I can only do something so much, right? If I want to do an experiment on 6 individuals, put 30 in the control, put 30 in there, unless it's like an online survey, right? If I do it here in Chicago, most of the people probably live within driving distance. But if I think that's not, I can at least, well, that's means that they're not quite random, right? Because it's not people from all over the country. If I publish my results, someone in Omaha can do the same study, right? And if they get the same results, it's probably not dependent on the fact that those people are from Chicago because it worked when they were from Omaha. Someone in Australia or New Zealand or Zimbabwe, right? Or Benin could do the same study and see if those results. Confounding is something that can happen, right? When you're not able to duplicate. Or you're not able to distinguish between the effects of different factors. Confounding in an experiment is something that you can try to avoid. In an observational study, it's almost impossible, right? The example that I did with the that was an example of confounding, right? Because of the way the observational study was designed, I mean, we have common sense, right? They was able to disentangle the effect of ice cream and the temperature, right? We use common sense. But let's say that you were an alien from another planet, you don't understand how anything works here, right? If they had the results of their observational study, they wouldn't be able to tell were the results because of the increase in temperature or the increase in ice cream consumption or some synergistic effect of both, or 30% due to one factor, 70% the other. So the best way to avoid confounding is to not have, you got your two groups, group A, group B, right? These are like, you want to make group A and group B like 2 jars of peanut butter from the store. They're the same, right? But you do something to one, you don't do it to the other one, right? Now, peanut butter might not be a mix because, people are all different kinds. So more think like well-shaken trail mix, right? 2 things, right, have this group. Should be, right? If the group samples are large, right, and they're randomly selected, this group will have roughly the same percentage of Hispanic folk in this one as in that one, right? So if they react differently, it depends on, right? Race can be important for certain things. It can be age, be income, educational status, right? Where people grew up, what they do for their job, right? And these are people. It could be the same thing. It could be armadillos or plants or bicycles, right? So the ideal is A and B should be the same except for the treatment that's being applied to A and the non-treatment that's being applied to B. Same except treatment, right? And when we're talking about people, right, you accidentally mentioned the Mandela effect, right, when you meant something else. But the Mandela effect is the way about how our mind can play tricks on us, right? We're very suggestible, right? If enough people say something, we can all trick ourselves that we remembered something happening, right? And they can see this in trials, right? I mean, I've done that. I mean, they do this in some law school classes. Maybe I'll do this someday. They have, right? I would be teaching class, have someone, janitor, come in, right, and do something, right? And maybe he knocks over a trash can and get attention, right? And people are like, okay, that was weird. And I come in and, an hour later, right, let's say he's wearing a green jacket, right? I raise my hand and I say, what jacket is that? And I tell Bob, I say, come on, Brian. He's wearing a red jacket. You're all gonna say it was a green jacket, right? And I call you three first, right? I talked to Mark, he's not, he might, it's the power of suggestion. He's like, okay, they all said it was green. I remember it being red, but now I'm going to tell myself it was green. And then when I'm asked, I'm going to say it was green, right? There's so many ways the mind can play tricks with you. So the fact that people know, right, in the example of the weight loss drug, right? The fact that you think you're taking a drug might, or especially if it's something more psychological, this drug is supposed to make you happy. You either be in your mind that's bullshit, no thing can do that, so you'll want to argue against you being happy, or you'll think that it does work, right? So the best way to do that is for everybody in the study, not just to, right? So if the two groups are different in 2 ways, one, they actually took the drug, and two, they think, one group thinks they took the drug and one group thinks they didn't, right? They're actually different in two ways. So if you're able to deliver the drug in some way that the patients don't know, right, then you can really see the effect of the drug, right? Like this happened when they were doing the COVID vaccine trials, right? I mean, a lot of people were excited because we were really scared of it. I'll sign up for the trial, but some people were getting injected with nothing, right? Because they wanted to see, and that could be one, right? If you're in a trial, right, for a COVID vaccine and you are told you're getting the experimental vaccine, you'll be like, cool, I don't have to be as worried. I can be a little bit more loose on protecting myself, right? So that would be another way that, right, like that the two groups could be different, right? So it could just be that. And that could cause it, actually, the people who got the vaccine get worse. But if you don't tell who's getting the vaccine and who isn't, people like, I don't know if I got it, or I don't know if I did, so I'm just going to behave the way I am. That's going to be the behavior then, at least of everybody in both groups should be the same. Now, of course, this isn't always possible. Let's say I'm doing a study on how massage affects mood. What's a placebo massage? I don't even know, right? Like that's not something that you can, right? Or if you're eating ice cream, right? You either know you're eating ice cream or you're not, right? So it's best to be able to do these things, but it's not always possible. A double blind, right? Imagine I'm the one that's doing this experiment, right? I'm giving you guys a pill that I say makes happier, right? And the only way I can do that is interview people. I'll be like, Damari, how's your mood been in the last couple of weeks, right? Whatever. I'm asking these questions. I want this drug to work, right? It's my drug. So even if I try my hardest to be professional and to be non-biased, there will be bias, right? So if I know, right, there might be a placebo, right? I know Jamari got the sugar pill, right? I know that Heath didn't, right? Heath got the real treatment. I might unconsciously in my notes play up change in Heath's mood while playing down the one in Jamari's, right? So a better way to do this would be somebody else. Maybe Ashley here, she knows which of you had the placebo, which had the treatment, but she's not doing the interviews. I am, right? So all I can say is subject A, right? Jamari, Heath's mood's improved. His mood is about the same as it was a week ago. And only she can say, all right, he's in this group, he's in that group, so that can help us figure it out, right? So if the experimenter doesn't know, right, it's best when neither side, either those who's making the data or those who are in the experiment know. So that's called a double blind result, right? So only one person knows, and they only disentangle the data at the end when there's no chance of bias. So that is the ITO. Okay. I'm going to give you 5, let's see. Any questions on any of the stuff that I've said? I know I've given you a lot of stuff. Maybe none of it was too complicated, but I just want to make sure that I didn't say anything that wasn't clear. Okay, so let's take a 5-minute break and be back at 1:56, right? And yeah, if you need to, we're going to eventually be using your laptop, so we'll get to that. Oh, right. Okay, don't think I forgot about those of you who won for Mingo, right? So I have 3 treats, 2 prizes, and you can, the earliest to win is that stuff. 3. Okay. No problem. Ash, where are you? Let's do right. Okay. 2. All right. And as the third winner, your prize is predetermined, but it is a big honey bun. We'll see how, we're doing an experiment. I left it in my car overnight, so we're going to see what the examples of It's not more, it's probably, it's cold, right? So we'll just see that, but there's no idea the food getting damaged. Might be damaged, but it definitely won't have, you know, bacteria or anything in it. It's not cold instead.
It's still there. It's a problem, but,
All right.
What's good here?
Let's get my five in.
Yeah,
Yeah, Simon, yes.
We did.
no assignment due. We'll have an assignment that's due, I think. Next Wednesday? Yeah, or something like that.
That's the, survey about.
Oh, that one, yes, yeah.
So I'm just trying to get us, so I remember you was talking about like two. You got the bias one, you tell them, oh, look at it going on.
Yeah,
You tell the price, is the golden one.
the gold. Let's see, so placebo is where the group, you don't know if you're part of the treatment or not.
The golden standard.
Golden standard, right, double blind sample, right? So the people take ideally, so golden standard would be that I'm doing an experiment. Each group is randomly selected. One group is having a treatment, the other group isn't. Okay. Let's come back together, right? So one thing that we found out about, like all the confounding, right? Like for the therapy example, I gave the ice cream example, right? It's the effect that we saw wasn't due to the factor that we thought that we were studying, right? There was something else that was different about the two groups that was causing the effect, right? So the best way to avoid that, right, is if you choose two groups, right, randomly, and the groups are large enough, they're not likely to be that different, right, just by chance. So that's why randomization is the best way to select a sample, right? Now, randomization can be difficult, so if I wanted to select, so like one way I could do that, like if I wanted to select 30 students from XXU to be part of some sort of survey or a sample that I'm collecting, right? I could use a random number generator to randomly generate some 30 student numbers and choose those 30 students, right? Or maybe my random number generator would choose some numbers that don't belong to students, well then discard those, and then just keep generating random numbers until it is 30 students, right? But that often is not possible. So let me tell you some of the other ways that, right, you can sample. And it's good to understand these because you'll have to, right, like on the celebration, I'll give you a example of how a sample was collected, and you'll have to identify which type of method was used. So one is systematic sampling, right? So systematic sampling means you have some sort of system that selects who is into your sample and who is. That's or something. All right, so some sort of method, right? So for perhaps, right? Has anyone ever driven across an international border like in Canada or something? Yeah, I have. I'm from Washington State, so I've probably done it more than most folks here, right? Certain inspections take a long time. They don't have enough personnel, right? Or maybe more example is going through TSA at the airport. Perhaps every 100th car, they decide to do a extra screen, right? Just to check. Or, right, here's an example, they're doing every third car, right? So there's some sort of system, right? Another way could be, right? If I want to create a sample, right? I get a list of all my students, right? Put them in some alphabetical order. First student, sixth student, 11th student. It doesn't necessarily have to be equally spaced, but there's just some sort of system that selects each individual, right? So that is an example of systematic sampling, right? And that can be close to random, right? Like if you're thinking about cars that come through, right? Like a border crossing, the order that comes through, they shouldn't really be like, that's not really that important, right? So it shouldn't be that different, right? Or if I'm doing that with people in alphabetical order, sure, I'm never selecting two people who have very similar last names, but that shouldn't really matter for most things I might be studying. So that's a systematic sampling, right? Choose a starting point, select every case element in a population. Here's the worst, but the easiest, right? Convenient sampling, right? I'm getting older. I used to think myself as a young folk, but I'm getting closer to, I'm now halfway to 40. So I want to know what young people think about, I don't know, presidential election, new policy on TikTok, whatever the hell, right? Convenient sampling is, I got 20 young folk right here, I asked you, right? Now, you're all students in my STAT class, so you are all similar in a lot of ways that might not be representative of all young people. So if not, this is usually very bad, right? But it's convenient, right? I need 30 people for my sample, so I go to the mall or the supermarket and just keep talking to people till I get 30 people, right? So something that is just convenient, but I'm not really trying to randomize or do anything, right? I put up a poll on Facebook, first 10 people who answer it, that's my sample, right? These are convenient samples. Not very good. Right, we get the two methods we have so far. All right, systematic convenience. This is one that students struggle with a little bit more, right? So stratified sampling is where you divide the population into different subgroups and by some characteristics, and then you create a sample by choosing a sample within each of those subgroups, right? So for example, if I wanted to create a sample if I need a small sample, right, and I want to be representative of the population gender-wise, right? If I choose 10 people randomly, I can easily choose 7 men and 3 women, right? So by chance, that sample would be non-representative of the population as a whole gender-wise. And if I think gender is going to be a big part of my study, or I think it's going to be a co-founding part of my study, I might, instead of randomly choosing 10 people, I could randomly choose, like I did here, 3 men and 3 women, right? So this is stratified in that I put groups up, right, and I select within that group. This could be a way that you can try to get around some of the issues you might have with confounding, right? So one thing that's unfortunate, right? This is an example of environmental racism, is a lot of areas that have more lead, right? Where people get more lead exposure, happen to be poorer areas and minority areas, right? And it's unethical to expose people to lead intentionally, right? So I can't do an experiment. So if I want to do an observational study where I follow people who've had high exposure to childhood lead and low exposure, I would maybe want to create strata, right? I would want to create a high income, middle income, and a low income strata, right? And make sure that maybe not that each strata is equally represented within the sample. It doesn't have to be 1/3, 1/3, 1/3. But if it's 1/3 low, like if it's, let's say, a quarter low, half middle, half a quarter high, I can make sure that that's in both the lead exposure and the non-lead exposure samples, right? Even though, right, those groups are more representative, right? Those groups are overrepresented in one size. By creating them to be equally representative, I can get around some of the confounding, right? So important idea with stratified sampling, you divide into groups and then you select a designated number within those groups, right? That's one way that they do polling for elections, right? It turns out Republicans or conservative voters are a little bit less likely to answer surveys on the phone. Young people definitely are, right? So they might call until they get a certain number of young people, right? A certain number of old people, right? A certain number of people who identify as Republicans, a certain number that identify as Democrat, based on what they already think is in the population, right? So Something like that. So if you can't really get something that's simple random because of voluntary response bias or whatever, some ways you can try to do that is decide like certain characteristics, what percentage of your group they should be, and then randomly select within that group. Do we kind of get this one, right? So best idea is, the archetypal example is, I want equal number of men and women, right? So instead of randomly selecting individuals, I randomly select 3 men, randomly select 3 women. Or I want to have 100 people in my sample, so I want it to be racially representative of the United States. So roughly 14% of the United States is African American, so I randomly select 14 African Americans, right? So my sample is representative of the United States in that way, right? About roughly 12% is Hispanic. I want to make sure that there are 12 Hispanic folk in my sample, but those Hispanics within that group, they are randomly selected. Questions on stratified sampling. Hopefully when you guys do the homework and write just ask questions, you'll be able to kind of, they will give you examples and you'll have to classify them, and that will help strengthen these. So cluster sampling is somewhat similar to stratified sampling in that you divide the population into different groups. But notice in the stratified sampling, you create a small number, typically of groups, and you randomly select within that group, right? So you're creating groups, and then you're not selecting the entire group, right? Not all men are in the sample, not all women, but some men and some women are in the sample, right? So here in cluster sampling, right? You divide the population into groups, typically meaning more than you would in stratified sampling, and you select that entire group to be in the sample, right? So here's a picture, right, of a city map. If I want to get a survey that surveys a lot of different people across Chicago, and I wanted to roughly cover a lot of different parts of Chicago, I could choose to sample one person on each street in Chicago. That's going to take a lot of time, right? So and if it's a door-to-door survey, I have to send a worker, I have to go to every street, right? That takes a long time. Another way would be to, so if I choose one person from each street, that's stratified. If I say choose 20 streets, interview every person on that street, of the 20 streets I choose, that's an example of cluster, right? So in both cases, you choose groups, right? But it's different how you use the group. So in here, choose some, let's see, I'm going to just say subjects, assuming it's people here, but it doesn't have to be. From each group. So here I'm dividing into 2 groups. I'm selecting some men and some women, but not all of them, right? But of all the groups, right? Here there's 2 groups. If I did it maybe on like what decade you were born on, right? I would select some number of people from each decade. There would not be a decade where I'd leave people out. In cluster sampling, I divide it into groups, but I would choose only some groups and everyone in that group. So this first diagram, I got 3 groups, and I'm choosing part of each of them, right? So this would be systematic. This would be cluster. Yeah, question. Okay, so in stratified sampling, you divide your population into non-overlapping groups. And then you choose subjects intentionally from within each group, right? So it could be men and women, So let me just give the idea. Let's say I'm selecting people from Chicago based on where they live. So one method would be to divide Chicago into, let's say, 100 different sections. In the stratified example, maybe I choose 10 people from each section. Right? So notice every group is sampled and part of every group is not sampled. The cluster version would be, I'm going to use that grid, I'm going to divide Chicago into 100 segments, and I'm going to just choose 3 of them, but I'm going to interview every single person within that grid, right? So instead of taking a little bit of everything, right? I'm taking all of some parts of it, right? So when you're grocery shopping, right? If you're a jackass, you're doing a stratified sampling, right? You go to the grocery store, you want some peanut butter, so you open every jar and take a spoonful of that out, put it in a bag and try to pay for that, right? You are definitely going to never be invited back to that store. So when you're grocery shopping, you don't do stratified, you do cluster. I'm going to take this jar, and this jar, and I'm taking everything in the jar. You're not going up there and be like, I would like to buy half of this jar and half of this one. Can I do that? I'll say, get the F out of here, right? So I don't know, that story is hopefully funny enough that we can remember it. I'll have you talk a little bit about that. Multi-stage sampling, right? This is more complicated. Maybe you do some combinations of all of these, right? We're not going to do a ton of examples, but sometimes it's one where you might combine different methods. Okay, here's possibly the hardest thing. What's the difference between, I know this is getting boring, I promise we're going to be doing some stuff, right? And as opposed to having to listen to me yammer pretty soon. So what's the difference between a simple random sample and a random sample, right? So in a random sample, each member of the population is as likely to be in the population, right? So I can choose a random, so in a random method, right? Bobby, Myra have to be equally likely to be in the sample, right? But so a simple random sample means that any group of the same size is equally likely to be in the sample, right? So it is a stronger condition. So let me just kind of give you some ways of creating a random sample that's not simple random, right? So for sake of argument, and this is definitely not true, right? Let's pretend that every class let's pretend that every student has a class at 1 o'clock on, like we do, right? Every student has a class at Monday that meets at 1, right? At SXU. And all of those classes have the exact same number of students, correct? All right, not correct, but let's just imagine that, right? I could do a systematic sample where I choose 1 student from each class. And that's my sample, right? Now, every student has a class at 1, right? So every student could be chosen. Any student could be chosen, right? And each class is the same size, right? So any student is as likely to be chosen as any other student, right? We agree that every student at all of SXU, right, would be equally likely to be chosen, right? Because 1 student is randomly being chosen from each class. So that sample, right, Bobby, you're as likely to be in that sample, right? We're randomly choosing 1 student here. So Bobby, you're as equally likely to be in that study as Ashley, right? But it is not a simple random sample because based on the way that study is, right? I select 1 student from each class. If Bobby is in that sample, Ashley is not because she is in the same class as you at 1, right? So while it's random, not simple random because there are groups of 2 students, right? The group of you and Ashley is the probability of that group of 2 students being in the sample is 0%. The probability of Bobby and some student who's not in this class, they have some non-0%, right? Right, so whatever class is meeting next door, if Cindy is in that class, Bobby and Cindy could be in the same sample, right? So there's some non-zero percentage that they're in that sample. But Bobby and Ashley being in the same sample, 0%, right? So how would I avoid that? Well, maybe I would choose, instead of choosing classes and choosing a student within that class, just choose students, right? If I randomly generate, we put every student's name in SXU, right? Just like the lottery style, giant bowl, pull out the names after spinning it around enough, right? Bobby and Ashley are as likely to, that combo of people is as likely to be in the study. Keith and Brian, that's Keith and Bobby, right? If I chose these three, it's as likely the three of you will be in that study as the three of you, right? So in the sample. So there are ways that select people randomly that do not select them simply randomly, right? Another one might be, all right, so I put all the students in alphabetical order. I randomly choose one student, right? And then I choose the student that comes immediately before them and immediately after them. Unless they're at the end of the list, then immediately before, after, and then wrap all the way back around to the front of the list. Does everyone understand what I'm saying, right? So since every student there is also equally likely to be in that sample, right? Because the first student is randomly chosen, right? So, but if you're randomly chosen to be in the sample, the other two students are predetermined, right? They're before and after you on the list, right? So, right, people who are not adjacent onto the list, right? Assuming what your last name is, Dan and yours is. Right, you're not next to each other on the list, right? So if he's in the sample, you're not, right? But whoever's next to him on the list, right, they're more likely to be in, that combo is more likely to be in than this combo, 0%, right? So that's the difference between random and simple random, right? Here's one of the examples that I have. Right? So this is probably one of the more tough ones to understand, right? So that is totally fine, right? So any questions on this? It's random and simple random. I'll give you a couple of moments to talk about that. So anyone in here does not have their computer? So, you do not? All right. Mine being attempted to demo for the whole class. We're not doing that. I'm just gonna give you instructions on how to access the online homework system and the class is following. It's not a big, so I'll just have you log on to the classroom computer and it'll be fun, all right? All right, so I am going to stop this for a while, and so this is what you're gonna do, guys. Talk about the difference between random and simple random.